Hello all, welcome to Learning Mathematics. Today we have chosen the topic for our discussion is LCM, least common multiple. So let us wait no more and directly jump into today's agenda. First, we'll understand the definition of LCM, then we'll elaborate more on understanding of what exactly LCM is, and finally we'll try to understand some tricks for solving LCM related problem little quickly. So let us jump into the definition of LCM. There are two versions of definitions available. The first definition, let us go to the first definition. It says the least common multiple of two or more number is the smallest number among all the common multiples of the given numbers. What about the second definition? Let's see. The least common multiple or lowest common multiple or smallest common multiple of two integer a and b, usually denoted by LCM AB, is the smallest positive integer that is divisible by both a and b. Okay, it is little difficult to understand, isn't it? We'll have a more elaborative discussion. But from these two definition, one thing is common, is multiple. So what is multiple? Let us first understand that. So multiple is a number that may be divided by another without remainder. So it is pretty straightforward. So a number that may be divided by another without any remainder. So 4 is a multiple of 2 because 4 can be divided by 2 without any remainder. Okay, so we have already discussed on the definition of multiple. Let us understand that with some examples. So what we'll be doing here, we'll be dividing, uh, we'll carry out division between two numbers, 6 and 3. So we'll be dividing 6 by 3. Let us do that. Here is your 6 and we are dividing 6 by 3. So you know, if we divide 6 by 3, your quotient will be 2. So 3 2s are 6 and there is absolutely no remainder. So out here 6 is being completely divisible by 3 without leaving any remainder. So 6 is the multiple of 3. So if one number is being completely divisible by other number, then the first number which we are dividing is called the multiple of the number by which it is being divided. So fine then. So will you be able to tell me some more multiples of 3? Yeah, it is pretty easy, isn't it? So 3 has got multiples. So these are the numbers. Probably 3 is obviously, because 3 is being divided by 3, it can be divided by 3. So 3 is the multiple. 6 we have already said. 9, 12, 15, 18 and so on and so forth. Okay, so let us take another example. Let us consider 2 is one integer. So will you be able to give me the multiples of 2? Yes, it is pretty easy and straightforward, isn't it? So the multiples of 2 are 2, 4, 6, 8, 10, 12, so on and so forth. So these are the multiples. Okay, so let us go back to our actual discussion of LCM. So we know the full form of LCM is least common multiple. So now we have understood how to find out multiple. Now we will be discussing again how to find out common multiple, and then we will identify the least of all common multiples. So let us go to our next discussion. Okay, so we have understood what exactly multiple is. Now let us try elaborating it using some more examples. Let us take our old numbers 2 and 3, and what we will be documenting here, we will be noting the multiples of 2 from top to bottom. So the multiples of 2 are 2, 4, 6, 8, 10, 12, 16, there was a 14, I'm extremely sorry, 16, 18, 20, and it will keep on continue. Now we'll be writing the multiples of 3, and it will be 3, 6, 9, 12, 15, 18, 21, 24, 27, and it will continue also. So here are the multiples of 2 and here are the multiples of 3. So what the LCM stands for? LCM stands for least common multiple. So let me write it down here. So we have now documented, we have now noted the multiples for 2 and 3. Will you be able to identify the common multiples among all these multiples of 2 and 3? Yes, it is pretty straightforward. The multiples of 2 and 3 and the common of them are 6. What else? Is there any other common multiples? Yeah, there are more. So 12 is another common multiple. Yeah, here you see 18 is another common multiple, and if we keep on increasing the multiples, we will get to see more common multiples between two numbers 2 and 3. So let us write it down. The common multiples are 6, 12 and 18. So if you can see, we have identified the multiples. Now we have identified the common multiples. Okay, will you be able to tell me the least number out of all the common multiples that has been identified? Yes, 6 is the smaller one, or 6 is the lesser one, and 6 is the least one. So 6 will be LCM, least common multiple of 2 and 3. Okay, so we have discussed the multiple, its definition, and we have also elaborated same using some examples of identification of multiples. Then we have seen how to identify common multiples between two numbers, and we have taken an example of 2 and 3 to explain common multiples, and then we have also identified the smaller of those common multiples which will ultimately give us the answer of LCM, which is least common multiple. Okay, so let us understand that, because this is more or less explanation of LCM, but now we'll be taking you through the actual process. How do we solve problem related to LCM of different numbers? Normally you don't expect to give you 2 and 3 and it will be asked to identify LCM. It will never happen. There will be big numbers, and how to get LCM of all those big numbers we'll see through some process. Okay, so let me first write down some numbers for you. So probably 4, 6, 8 and 12. So if we have been asked to identify LCM between 4, 6, 8 and 12, so what exactly we have to do? We'll first write it down like this: 4, 6, 8 and 12, and then we'll identify some common factor by which all or most of the numbers are divisible. So we'll keep on dividing using factor till we ultimately get 1 against all those numbers for which we have been asked to identify LCM. So if we can see the number by which all these numbers will be divisible, because they're all even numbers, it will be 2. So if I divide 4 by 2, I'll get 2. If I divide 6 by 2, I'll get 3. 8 by 2, I'll get 4, and 12 by 2, I'll get 6. Now will you be able to tell me any common factor among them? Yes, again 2. But here 3 will not be divisible by 2. So we'll bring down 3 as it is. This is how what the process is through which we get LCM. So again I'll divide it by 2. So here I'll get 1. 3 cannot be divided, so 3 will come down as it is, and then 2 and then 3.
Is there any other factors by which most of the numbers can be divided? Yes, 3 is the factor. So let us use 3 to divide. 1 cannot be divided, 1 will come down as it is. 3 can be divided by 3 and it will become 1. 2 cannot be divided, so 2 will come down as it is, and then again we will get 1. So our final intention is to bring all those numbers to 1. So how can we achieve that? We'll be able to achieve if we can divide this number series by 2. 1 cannot be divided, it will come down as it is, 1 as it is, and then the remaining 2 will become 1, and finally 1 will come down as it is. So now we are able to achieve our target of reducing all these numbers to 1 by using division method. Now the process of LCM for all these numbers will be the product of all these factors. So it will be 2 into 2 into 3 into 2 multiplied by all 1. Even if I don't write 1, it doesn't make any difference, because any number, if you multiply it by 1, the product remains the same number. But yeah, as it is a process, so I have noted it down. But while you are executing your problems in your problem sum, probably you would like to omit, because this doesn't carry much of an significance. Okay, so the LCM will be 2 2s are 4, 4 3s are 12, and 24. So the answer is 24. So 24 is the least common multiple for 4, 6, 8, and 12. Will you be able to see through our earlier way of explanation how we are achieving 24, whether really it is the least one or not? Yeah, let us quickly do that. So if I write down the multiple of 4, it will be 4, 8, 12, 16, 20, 24, 28, and 32. I think we'll be able to manage with these numbers. What about 6? 6, 12, 18, 24, 30, 36. What about 8? 8, 16, 24, 32, 40, so on and so forth. What about 12? 12, 24, 36. These are all the multiples of 12, 48. And what is the common multiple among all those numbers? 24 is the common multiple. Is there anything less than 24? No, there is nothing less than 24. So we can comfortably declare 24 is the least common multiple of 4, 6, 8, and 12. Okay, let us quickly understand by using one more example, using our legacy process of solving LCM related problem. So the numbers that has been considered for these discussions are 5, 7, 12, and 15. So how do we identify a multiple? We just write down those numbers and we find out the common factor by which all or most of the numbers are divisible. So here we see the lowest common factor. Obviously the lowest one is 3. So 5 will come down as it is, 7 and 4 and 5. So what is the lowest common factor by which all or most of the numbers are divisible? Here it is 5. So 5 become 1, 7 will come down as it is, as it is not divisible by 5. Same is the case with 4, and then 5 becomes 1. Now our ultimate target is to bring all this number to 1 by using division method. And how we will be able to achieve that? If I divide it by 4. So 1 becomes 1, 7 remains as it is, 4 becomes 1 and 1. And then finally, if we divide the series by 7, we will be able to achieve our target of having a result of 1 through division method. What will be the LCM of these given numbers? It will be the product of all these factors. So it will be 3 multiplied by 5 multiplied by 4 multiplied by 7. So 5 was 20, 60, and 60 into 7 is 420. So this is your multiple of the numbers 5, 7, 12, and 15. It is not only the multiple, it is a common multiple of 5, 7, 12, and 15. It is not only the common multiple, it is the least common multiples of 5, 7, 12, and 15. And this is how we'll be able to achieve the LCM for any given number. Now we have come down to our final agenda of today's discussion of having some tips and tricks available in our bucket so that we will be able to solve LCM related problem little quickly and comfortably. But if you ask me, I would always prefer to stick to my basics and follow the normal process of solving any problem, because that's how we make our base strong. But anyway, as this is a part of our agenda, so we'll not wait anymore and we'll start our discussion. So normally, consider some numbers for which we have been asked to identify LCM. So I've taken for an example, these are the numbers 2, 4, 8, and 16. So out of these four numbers, if you can see, 16 is the biggest one, and 16 is also divisible by 2. So first we will choose the big one, the biggest one out of the allocated number series for which we have been asked to identify LCM. And if this number is being divided by other numbers in those allotted number series, you just scrap out the number if it is being divisible. So 16 is being divisible by 2, we just scrap it out, strike it out. Now the remaining two numbers, is 16 is being divisible by remaining numbers, any of the remaining numbers? Yes, it is being divisible by 4, we'll strike it out. Is 16 divisible by any of the numbers, remaining numbers, which is not yet been striked out? Yes, 8 is remaining and 16 is being divisible by 8, and the quotient is 2, 8 2s are 16. So we can easily strike it out and 16 becomes your LCM. So LCM for 2, 4, 8 and 16 will be always 16. This is the first tricks. Now let us come down to the second trick. Now I'll be choosing the same number series by altering one of the number. So 2 remains 2, instead of 4 I'll put 5, and then 8 and 16. So what will be the LCM if we can identify on a fly rather than solving through our normal division through common factor process? Okay, yeah, we will be able to do that easily. 16 is the biggest number. Is there any other number which will be able to divide 16 without leaving any remainder? Yes, 2 will strike out 2. Yes, 8 will strike out 8. Now 16 cannot be divided by 5, and 5 is a prime number. So this type of number, when two numbers remains and one out of them is the prime number, we call this number series as co-prime, and the LCM will be the remaining number and multiplied by the prime number becomes your LCM, which is 80. So 80 is the LCM for 2, 5, 8 and 16, and you can try it out in your rough copy that this 80 is being divisible by all these four numbers, and if you follow the legacy process you will get 80 as an answer. Let us try doing taking another example and finding out whether we'll be able to solve it using some tricks or not. So here is your third point. So the point is, let us consider some numbers, and I have taken 2, 3, 5 and 7 as your numbers for which you have been asked to identify LCM. Now if you see, 7 is a prime, 5 is a prime, 3 is a prime, 2 is a prime. Okay, so we have taken this example 2, 3 and 5 and 7, and if you see, all of them are prime numbers. So the tip or trick to identify LCM for all those prime numbers is to simply multiply them. So the LCM of 2, 3, 5, 7 will be 2 multiplied by 3 multiplied by 5 multiplied by 7, and the answer will be 6 and 5, 30, 37, so 210. 210 will be the LCM. Now let us take another example and we'll see how to solve that using some tricks. Let us take a number series 2, 3, 5 and 16. Now find out the big number. The big number is 16. Is there any other number by which 16 is divisible out of the given number series? Yes, so you can always strike it out. The remaining two numbers are the prime numbers, and as we are already aware and discussed in point number 2, the process of identifying LCM between prime numbers and left out numbers is to simply multiply them. So here LCM will be 3 into 5 into 16. It will be 15 into 16. So 15 and 16, that is 0, 3, 9, 15, so 240. So the answer will be 240. Okay, so we have already discussed 4 tricks and will be concentrating on our final problems or final tricks for today's discussion on LCM. Again, let us take some numbers. The numbers which has been considered for these discussions are 2, 4, 6, 8 and 16. So the first thing that we normally do is to identify the big one, the big number. 16 here is the big number, and we'll be isolating those numbers by which 16 is divisible, and we'll be striking them out. Here 8 we can divide, 4 we can divide, and 2 we can divide. The remaining numbers are 6 and 16, and 6 is obviously not a prime number. And so the process of identifying LCM of these numbers where it is not prime, it is can be divided by other numbers, or it has got a common factors available, but it is not exactly divisible to each other. So 16 cannot be divided by 6, but they have got a common factors available. For this type of problem, the remaining numbers you simply do a LCM. So 2, 3 and 8 and 3, 1 and 8 and 8, 1 and 1. So LCM of all this number will be 2 into 3 into 8. The answer will be 48. This is the last one for today's discussion. So yeah, obviously if we identify the two numbers and they are not exactly divisible, but they have got a common factors available, so we do the LCM for the remaining numbers and easily identify, rather than carrying out LCM for all those numbers which has been given in the series for identification. Fine then. And will you be able to tell me if instead of 6 it has been given as 7? So 7 and 16 is the remaining numbers. Yeah, you are right. What you have to do, when there is a prime numbers available, we simply multiply. So LCM would have been 16 multiplied by 7, and whatever is the answer will be your LCM for this entire number series. I think that is all for today's discussion. Thank you so much for watching.